Hello and welcome to another video. This week, or today on this video, I want to look at this thing called microcorruption. It's like quite an old CTF where you have a map which is normally showing everything, including in New Zealand. Sometimes maps don't show New Zealand. It's more often than you might think. There's even places on the internet that are dedicated to doing this. Dedicated to showing all the maps about New Zealand. I think that's what I wanted to say there. Right, so what this is you basically have like a bunch of locks that are attached to things, and I think in the about it has, no, that's not the about that I wanted. Maybe this had it. Yeah, so this had like some user guides and stuff. So it's basically like you've got this like thing that does like a bunch of stuff. It gives you like all the user documentation, which is a fair amount of stuff. You can see things haven't gone down that much. Also a guide to the actual thing and like what the code might look like. But majority of the time you don't really need much of this, and I think one of these had like all the operations that you can do, which may come in handy in the future. Like if you want to assemble your own code, you can like make your own shell code to come back. I just realized I didn't check where the camera was facing beforehand, so it looks like you should see me, but potentially it should be like that. I think normally I have it like that because I don't know, I like to have it continuity. So what do you do in this microcorruption? You basically have a bunch of things, and every level you kind of get dumped into basically a debugger type thing, which I think I will do a thing and yeah, not have you on this. Yeah, surfing keys. It's so you can like kind of go to things easily, but if it's on this, I might like type as if I think I'm in the debugger console, but I'm not actually selected, and I'll push R and it will reload the site, and it can be a bit frustrating. But yeah, so basically what this does is you have a debugger, so you can like kind of you want to continue. Yeah, you continue not to R. And you can kind of step through and see what functions it calls, and it will ask for input at some point, and what we could do is, I don't know, we could just try password. That's sometimes a good password. And then it kind of like dumps us into the middle. You basically do an interrupt to call, ask the user things, and one of those PDFs edit might be useful later. But what we could do is just do a continue because we have this and we can step into, and maybe the breakpoint could be here. So here you can kind of see this is what it is doing to check the password, and the end goal is basically put a 1 in R15, I believe, because, well, really the end goal is to call unlock draw, and really the end goal is call int with a particular value, the 7f. And however low down you go is really up to you. But yeah, in this case, basically the main will check the password and then it'll test R15. And then based on that, you either get invalid password or you unlock the door. And you can get all this by like kind of looking through the main and reading the assembly. I mean, it's a different assembly language to what I've developed in. Like, it's not x86 assembly. It's like, I don't know if it's like made up or it is actually based on like an actual thing. Like, it seems like it might be, but like it's from Texas Instruments. But it also may not be. I don't know. It was a thing that does a thing. So, like, this is assembly language for this little chip here. It can do a thing. It sometimes has hands attached to it, and so forth. But anyhow, I am not really interested in the docs at the moment because I can kind of read through and kind of gauge what it might mean. So once we're in a state that we've read some input and we can kind of see where the input got dumped in. We can see password there in the memory. It's actually kind of a cool little program. You can like scroll through the memory and do stuff. You can see all the states. If you hover over the status register, it will say whether what the bits mean. There's currently none set, so you can't really do anything. So where are we? We're here. So, right, I've kind of got a breakpoint in a loop. So this check password, we can see that it kind of starts with maybe R15 set to a certain state. And if we look at 439F, we can see 439 and F is the end here. So we've pushed continue a few times. So we've kind of gone to this point. But what it's kind of doing is it's moving that into R14, and then it's incrementing the pointer. Then it's incrementing R12, which is currently 3, so it might be just it started at 0. And then at the end of the string, we should have a null byte, and here it will test whether it was a null byte, and if it wasn't, it will jump back. If it was, it will then do a comparison on R12, and you might think R12, well, that was just counting up each time this loop went round, so it's just going to be the length of the password, quite literally the length. It's not doing any checking of the actual password. And so if we continue and maybe like step to there, we can see at this point R12 is 9. I don't know if that is big enough. Maybe that's big enough. We'll have to scroll around to look at things, and it might be maybe a little jarring. This is potentially alright. So we can see here R9, R12 is 9, and that's what it's comparing against. Perfect. And here we've got a status register, and we can see that it has CZ. And I don't know, sometimes could be useful if you're doing jump Zs. So we'll do this comparison, and of course it is basically succeeds. we're now at this breakpoint here. You can tell by the red, it's actually a little tricky sometimes. But at this point here, we're basically saying, yes, that password was right because it was 8 characters long. That's all it did. And now we've continued down to unlock door. And if we continue there, cool, we solved it. Basically, that does that. So we're currently doing it in the debug console where we can kind of scroll around and see what things are. So what you're meant to do is do it with solve. And here we can maybe say our password is 1234567 8. So it's a different password to before, but if we do that, this just runs it and we have no access to the memory whatsoever. So sometimes you can just kind of look at the code and not worry about the debugger. But yeah. Alright. And whenever you start a level, it kind of talks about something, and maybe it will say this does a different thing. So this is like a Bluetooth thing. It doesn't have a default password, so we have to set it somehow. And it tells you about some things. So I guess here, what's this doing? So we do this create password first. That could be interesting to look at. Then we kind of ask the user for a password. We get password, and then we check password. So the create password and check password are good. Check password returns R15.1 by the looks, and if R15 is 0, it will say invalid password. Otherwise, it will say access granted or unlocked. Perfect. So let's have a look at create password and check password. Create password is here. We could maybe do that, and check password down here. So what's create password doing? It's doing a bunch of things. We can potentially step through this. Might be a little clearer. So if we continue, we had a breakpoint there, but I didn't actually need it. I think I clicked on it to show what was happening. But if we do that, and I just realized I might want this like there. That's all good. All right, so at this point here, we're moving a thing into 15. So it now has a constant, and now it's getting looked up in memory. So it's basically looks like we're getting 8 characters from this address 2400. So we can look and see what's at that address. Now it looks like there's nothing. So maybe this is actually little endian, and we should be looking at 0024, which would be 0, 1, 2, 3, 4. And this is just a bunch of zeros, so maybe it is actually pulling from a thing. Maybe this is actually getting it from somewhere else. Yeah, because it says it's 2400 there. So like, is it just in the middle here? Either way, it seems like it should be 0, but we're moving a thing into it. So if we step, yeah, that could be a little jarring. Maybe we'll just have it so it shows the whole screen. So at this point here, we've moved a thing into R15. So hopefully something has shown up. It should be a 3D. And in here, there is indeed a 3D at 2400, which is where it was going from. So this looks like it's just putting the password in. And we can kind of test this by maybe getting this 70. And maybe we can just copy this and we'll see, because it will ask for the password next. So we can kind of step through this. In fact, we can potentially thin out of there, and then this 240 has this weird password, which is potentially just the password that we did, and we can say it's hex encoded. And if we do that, where we put our input is, I don't know. Here, I guess it is this point here, right? So now we're checking our password, and we can see here E20 for that, and this looks like it's also doing kind of like a loop to get the password, make sure it's 8 characters, but also make sure that each of the characters are correct by having this comparison. And if it's not, then it'll just immediately exit out. So I think if we continue, you click on a thing and it just remembers you did it, and it says we solved it. So what we can do is type in solve and say that is our password, and the door is unlocked and operatives entered the building, and we can go back to the map and see that they have like uncovered more things. I don't know. But yeah, if we fly over to Sydney now, we can see that this lock has a deadbolt, maybe. So it's got some things going on. I mentioned something about memory, maybe. But we can kind of approach this a similar way. So we will get to main. So like it actually starts very low level. Like this is where we are at the moment, and we kind of do some stuff which is similar to how like normal programs get compiled. The main isn't actually the main point. There is a bunch of stuff that happens before main. And a lot of people don't realize that. Right. So what's happening in this? The main looks fairly standard. So it's asking us for a password, then it will check the password, it will check the R15, and will give us that access if needed. And maybe we are needed. Alright, so check password. What on earth does check password do? It's checking, so it looks like it's checking the actual bytes here. So what I could do is do a 2A3C. So I think this was the little Indian, so you have to go to 3C2A. Makes it hard for the dyslexics out there. But if I get all... see there, I'm doing the wrong one. If I get them all written out, does like a weird thing there. 4638. So this can potentially be my password. Yeah, it does kind of a weird thing after this check. It will set it to 1 and then maybe clear it after. But yeah, maybe if we could potentially just break there, just to see that we've got it around the right way. But if we do this and then continue again, we can see what happens on each step. So this says we have a 0 byte after doing this CMP. So we should continue on. And we can see that we do. So if we go continue the whole way, I must have clicked on that at some point. We can see that we solved it. So what if I do solve, click that, opened another door. So a couple more things got opened. And the aim is, I guess, to finish the whole lot. Right, so this one does some things. I don't know. Maybe it's got two things. Yeah, I don't know. That's just like filler text, I feel. So this main does a little different. So we go to log in instead of R15. I get what I'm doing. I'm like kind of doing a select, select like that to show it, but then I'll register that as a click, as it should. But maybe I should go off screen, but then you get like a little thing there. I don't know. But yeah, so this is jumping to login, and then afterwards, if it returns from login, it will clear R15 and then go to the end. And we actually want to get to unlock door at some point. So there's a test password valid. That could be something interesting to do it. Has some strings in the middle. So this looks like it's like arranged quite differently. And the login, what does the login do? So the login does a similar thing. So passwords between 18 and 16 characters. This is amazing. One frustration I have is sometimes if you're not using a password manager, for whatever reason it is that you're not using a password manager, and you try and log into a thing and it says, like, maybe it's just like a throwaway thing, and you've got just a password for that. But then it's like, oh no, you need some special characters. So you put a special character at the end, so you know it. But then when you come to log in, you don't know that it needed a special character. If you did, it would prompt me to remember that special character that I just always add. I mean, QWERTY's a good password, am I right? Much easier than password. You gotta like type a word. Though, to be honest, typing a word sometimes easier. It's got a little damp, that little can. Right, so we test password there. Then we test R15 again, and if it is 0, we jump to plus 32. Now, see, this is like kind of annoying that I don't really know where this jump goes. I can kind of just add 32 bytes on, but it would be cool if it showed somehow. But I would imagine that it would jump to this point here. So R15 has to be clear in this one by the looks. Otherwise, it will print a message testing if it's valid. and put that into there and then print that easy. And it does like a funny move byte. So we put a byte somewhere, but then so we might have like a canary type thing there. I don't know, that's kind of odd, isn't it? Then plus 50 would be at this point here and then do that. So we could potentially just run this and do something like password, and we'll say it's not here. And maybe see where this takes us. So I didn't actually do this. I kind of want to do a break at this point here and then again at this point here. But I also want maybe I did have a breakpoint there. Just to kind of understand what's happening here. Alright, so this does an interrupt call with 7D. So this maybe I do want to like do this, lock a tail. Yeah. Right, so what are the interrupts? Interrupt listing. Right, so if we look at this, we're calling 7D interrupt. So this is right. So this is asking the HSM if we have the password. So we do have to kind of maybe get the password right, but it had some fishy things going on. Kind of means that the password's not in memory, which I think it said at the start. Right, so what are we doing here? We're doing some weird stack pointery things. So R4 is like doing something. Right, so is this like doing some things? So around stack pointer, we just did a 0, but I think it was there, or maybe even at stack pointer, which is interesting. We could reset and kind of see what that was beforehand. Continue from there. Right, so we got like a 24, then 0, and 2,000 there. 200, sorry. Right, so we do this, and then at this point here, I'm not sure that did really much. Maybe it was already 0. Now we do some things we're like kind of dampening with memory a little. And maybe I want to know where this goes afterwards, which I can get from a thing. But yeah, what happens after this interrupt? So we get an interrupt, and R15, well, One of those was where my thing was, right? R14 would have been. No, R14 is. I don't know, 2-4. Maybe that's over and now. That's just gone skis. And then we get 7D out of that. But we're going to do a funny thing. Right, and we just get out there, so it does kind of clean up the stack. So if that is 0, which it is, so we kind of skip over that thing there. I see. So we're kind of given a clue, maybe, that we have to have passwords between 8 and 16 characters. And we can kind of see what would happen if we had something longer, maybe. So we've already done that, but that's all right. So then what is at this 2410 address? 2410 is this 00. Because we didn't move anything into it. But it's kind of expecting B1. But we could potentially control that. So what I can try and do is we're going to reset. And if we continue, and what was the thing it wanted? It was wanting a B1. So B1, 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 B, just lots of B1s. Maybe that many. And it is hit. So now what is like where my things end up? Did it? Am I being blind? I don't know. Like there should be a lot of B1s somewhere. Is it? I've got all these D's, but no, I don't think that's there. Maybe now that I've like come out of things. Yeah, so now I've got like a bunch of B1s. And we can see that 2410 now has B1, B1, which might just. So we don't really care what happens in test password valid. So we can take these out. Because we've just overridden the memory. So now it should do this weird call, should do that, and now access is granted. So yeah, I've still got that in copy, I think. It doesn't really matter. Wow, it seems, I don't know if that's how many I did, but what I can do is just go So maybe do that many. And the door is unlocked. Cool. So now we get another one. Perfect. Perfect indeed. Do, do, do. Just checking a thing. That's all good. Apologies. Apologies. So, what do we do here? We might have a hardware security module. So it's got some things. I don't know. Right, so they've taken out that basically buffer override. So what do they do instead? We do main, we do call login, easy. What are we doing? Test password valid. What do we do in was there a login somewhere? There was a login. I don't really need that there. So what does this do? Does similar thing, and we only really get to this access granted if R15, it happens just after that. So if R15 is not 0, so if it's set, then we do that. And we don't have a weird flag, but we might still be able to overwrite things. I'll see to that. And what's this doing? It's going through, doing the same thing. So it's doing that interrupt for that. And I think that's where we need a break. So if I continue and maybe do all those B1s again, and maybe continue. So, and I don't really care about that. And continue. So we're at this point here, and password's not right, that's all right. But our stack pointer is like in the, maybe redraw. It's in the middle of all these B1s. So where we're going to return to is, if we can see current instruction is that, but our program pointer is B1, B1. So what we could do is like we can see memory addresses. I guess we overwrote stuff. What we can do is maybe reset this to a kind of working thing. We kind of want to just jump to this address maybe. See what happens if we just jump to that. So we could probably just go. We would have to do 4644, I guess, and just have that a lot of times. What we could do is actually work out how many times you would have to do it. That is sometimes a more useful thing. In this case, we don't really care too much. So we're overflowing basically the stack on this. And it is because so this is like subtracting 10 or 11. Surely more. Oh, if it's 0. No, so this will be subtracting 16, I think. So it's basically saying we're allowed 16 characters, and we'll put that on the thing. Or maybe it's here. 15. Yeah. Oi, that's going to add a lot of things. So maybe it's just actually just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have the benefit of seeing where things end up. So at this point here, we can see where we are, and the things I had 4, 6, 4, 4 are like there. So I need 1, 2, 3, 1, 2, something like that. So we go reset and continue, and we do that and continue. So at this point here, I was off by like a gross amount. So if we do that, that's all right. Reset that. Continue and do that and continue. So I think at this point here, we step into unlock door. So we basically overwrote everything on the stack up until the point where when we return, we pop the address that called us off the stack, and we've overridden that, and not much more. So we're nice and tidy. But it also means that we control these bytes in essence, and potentially more. But for now, that's that. We will do that. We got a bunch more things. I can't remember if it's. I've done this once a long time ago, though I'm not sure I actually finished the last level. I can't remember if it gets harder as it goes on, or it goes in a different order. Because like they're kind of showing up in odd orders. And it's weird that I know where they all will be. Gosh, it's got military grade encryption. Won't be. Guts, that's not a good business attitude. It's the excuse for training them up. That's that. Go to random noise. Right. So what are we doing in this? It said it was a little different. So 4520 4520 is this. What's the password of this? That's what's happening. So, and then so both get set to that, but then we kind of overwrite both of them. These first two instructions seem redundant. So we do this encrypt with these two things, and at the end we do this, and we call this function 2400, which doesn't actually exist here, but what I think is it will exist in here, and I can see that this is kind of plain text-ish. like I can just see random strings in there. So I wonder if that was just, yeah, hard to know. It is most likely not secure. Otherwise, we wouldn't be sitting here doing a CTF. So I kind of want to know what this ink does. So the ink does a bunch of things. If we've got like a do nothing, don't know what the do nothing is, and I wonder when was it called. Interesting that disassembled some stuff. It's just like a bunch of loop type stuff. So I think the easiest thing to do is kind of run this. So these two things get set to that, but then they get overridden. And then we go into ink. I kind of just want to let it rip, let it do a thing. So it did a thing, and I assume we have code here now. So what we can do is like step and like step into this. Right, so it hasn't like disassembled it again. But we are at this point here, so I wonder if we can use their disassembler, and I think we can. We can copy, like, I don't know, that chunk. They probably don't use more. And in here, we can go disassemble, and it will tell us what that source code was. Which I guess it's that. And we can kind of verify this. So at this point here, we're doing this, and I wonder if I should split that out there, and so you don't need to see all these things. That's all right. But the instructions are interesting. So at this point here, we should be pushing two things to the stack. So our stack pointer is here. We've got nothing before it. So we should see R11, which is 0. So that's not that useful. And R4, that's also not that useful. But we see the stack pointer has moved there and there. So now it's 2 off the return address. We set R4 to be whatever the thing is. We also get to see the instructions here, but not nicely in here anywhere. So yeah, I guess what is this doing? And it's got like some jumps. Yeah, it does like a bunch of things. This kind of reminds me of, right, so this code is like probably not right. What we can do is like do F and it'll just kind of do that. And now we're kind of in the middle of the interrupt thing. So I kind of want PC to go back to being something in the 2-4 range. Right, so now we're kind of back to in the middle here, and we can kind of see where that is. So the 3150, it's an add C. I think it will be easier to search for 3150. So it was the add 6 to the stack pointer. It's heaps in there. Add 6 there. So we've just done this call, and that gets us our password. So our password should be somewhere in memory. There. And now what does it do? That's the important thing. So this is going to do another call. So maybe I want to do a breakpoint on 0x. How do I have to do hash 0x2464? So it's got a breakpoint in the memory of code that I can't see in the thing. It's bizarre, bonkers. But yeah, so we've called this, and this is actually the same function that we just came out of. So I think this is our int, and yeah, I wonder if that's our int, because we've just called something that has got us a password, and we do it again here. And here. So we call this function a bit, but depending on what arguments are sent to it. This one had a 2, so I wonder if that means this is interrupt 2 gets. But beforehand we had a 0 and another 0. Right, so what did 0 put char? So that was writing me output. So that was like, what's the password, I guess. And then this one, the 7F, was that the that's the unlock. Yeah, how do I get to there? So I want to get to this point. So that means that this at this point needs to be 0, which means that this, so we're at like this point here, and we've just pushed on 15, so that will be like where we have read memory into. Yeah, well, we can actually see what things are. So it wants -24 from this address here, 43F3. So 43F E. So it's kind of pointing at this address here, which is just random stuff, but that might be, well, then it wants 24 down from that. So 24 means I can just go down 2 lines. And then the 4 means I need to go back 4 bytes. So 1, 2, 3, 4. So this is just looking at my password. Easy. So I guess the password needs to start with CCHD and then some length of things. I think it just needs that. That's a short password. So this was like literally 2 bytes. CC8D. So if we maybe do a reset and then a continue, we don't need that. maybe we'll just do a break on 0x240 and it can just figure that out. I don't really need the encrypt, that just does some things. It's basically an unpacker. That's all right. This is just the bottom of encrypt, I guess. Well, where'd we end up? Yeah, I guess that's the 240. Perfect. Ask me for the thing. I'm just going to say this here. So these 2 bytes are doing that. And I probably should have done a breakpoint of where we were before, but what I can do is do fin twice. And now we get to the stack pointer. And I think you can do stuff. So this debugger does have some help you can use. So I think we can like read some memory, read Z bytes starting an expression. So we can just give an expression and nothing after, maybe just like 1. Oh, can you do manual? Oh no, it's just that one. It doesn't feel like a manual to me. So we can read from, we want to read from -0x24 of 24 of R4. And can that do that? It's done it kind of weirdly because it's just printing it out. Alright. But does that mean arg? 43F3. Right, so we'll do this compare and we'll just see what things end up as. We have a 0. I think this has done what I want. And yeah, then we door unlock. Gosh, it's just checking 1 byte, 2 bytes. You can like go work for these people. Right, so that was cool. What does this do? There's no function to unlock the door anymore. I think that means that we now have to explicitly send that 7F. Well, we need to put it on the stack ourselves. So we just need, yeah, we'll see what it does. I've got an idea. So it calls login. Perfect. So when it calls login, in fact, we can do like a thing here. So we have our stack pointer, which is, where's our stack pointer? Stack pointer is 3C. Oh, we're just in the middle there. So what happens is our stack pointer is now there. It was at this point here. Actually, no, I lie. It was at this point here. And what it's done is it's just pushed stuff onto the stack such that when you return, you just pop that off into your program counter register, and that's where it is. So what this is likely going to need is we need to basically overflow this somehow. And we can see that it's doing perhaps a similar thing. We are only allowed 16 characters. So what happens after the 16 characters is potentially just that. And I think I can like do progress maybe? No. My data. This kind of shows it in like a weird format. Well, I mean, I can get it from the old application, this, and solutions. It is just still this. I want to know what. Well, it'll just be the one that had this. Right, so I just want this because this is likely the similar thing that I want to do. But instead of this, I want there to be a 7F somewhere. And the return address that I want to go to, the 4644 is probably not right. But here we have a 7E. What does 7E do? That was the hardware thing. So we do a 7A. What we can do is we could actually just return to the 4532. Yeah. Which would require us to be 3245, something like that. So I think I want this to be my thing in hex, and we'll do this, and we'll finish from there, and we'll finish from there, and we'll finish from there. And I kind of want to continue from here, and we'll say nah. And here we have the 3245, and that is our int. Now, I wonder, because this is going to get the things that it needs into the wrong addresses, because like we don't actually want to just push it. Yeah. It just makes it easier if you have a function like that, but hopefully R14. No, so I think I want to go the other way. So maybe I'll do this, and we want to put the 7F afterwards. That's all right. You don't need to know that. So if we continue from there, at this point here, yeah, so we have 3245, but the 7F is on the other side of the stack. So at this point here I was hoping that right. Maybe I did want it round. Well, like I wanted to kind of break on. Was that like a thing? Yeah, it was just called, and I don't really want to break there. So one of the sides we want. It's I wanted a breakpoint there, but it had a breakpoint in a funny place. So the reason I want the breakpoint, right? So this is like kind of a good spot. So here we can see kind of what things look like in the stack after this. So this, we can't really see, like, can we see a back trace? Kind of like the 45A8 was where we were. 45 um 45A8. Yeah, so it was from here. So we pushed a 0 and an R. All right, so it is growing that side out. I think I know what the problem is. Right, so we'll probably hit that. Yeah, we're hitting that method every time we're printing a character. But I want some zeros there. I didn't copy that, but that's all right. So if we do a fin, and then like uh, from here, we should be in this function, and the yeah, I don't know. Maybe I did one at the 4. Something like that. I don't know. It's like not getting what I want. I kind of want int, but only after doing uh yeah, maybe that point there. So when we're getting the um yeah, so when we're getting this, I want to see what the stack ends up after this. So it's already pushed on a bunch of things. So 2 is where it currently looks. Yeah, that seems like the right place that it should have been looking, but we wanted the 7F there. How do we call um I mean, we could see something like 20 and just see if we are getting a thing. Um, but yeah, anyhow, that's what it should look like. And 1, 2, 3, 4, 1, 2, 3, 4. And here, like 1, 2, 3, 4. Maybe the address was doing that. And what I kind of want to do is change the 7F to a 20 just momentarily, just to see if it's does the thing that I want. Oh no! See, we're like right on top of it. that's not the case where it was before. I don't really want that. So I think I want to continue. At this point here, we've got something before the two. So yeah, I want like, I guess maybe like something like 1, 2, 3, 4. You guys go there. We don't really care too much about that. Well, maybe we do. Um, and we can do that. If we continue again, step from here. Right, so at this point here, it's got a buffer before the 70. I suppose, yeah, because int is now needing a return address. So this like is going to maybe some ends. So we're going to call this with 7f. So it's unlocked the thing. And like, where do we end up? So now we just end up nowhere. I thought that means it unlocks. Because all the other things, like if we look here that we had solved it, that was doing an ink. If we look at a simple one, if we look at this, we access granted unlock door, which is unlock door. It will push the 7f and then do the int. Maybe I'll do the old tutorial, and here we can do a break there. And so if we can do that, and it's like 8 characters, wasn't it? And we can send you to there. Was it not just where the tutorial? It should error out because like some of those characters are not hex, but I don't know. It was made like years before like CTS were like a fun thing. Right, so at this point here, this is kind of what our stack looks like. Did we, was this one that we like have decompiled? No, it just doesn't have thing in there. So it gets a thing into R14. So R14 is there, perfect. Pushes the stack register, it pops at the end, that's fine, it's saving it. We put that 7f in there. We swap the bytes. So I guess, yeah, that's just swap those 2 bytes in. We're now making this the status register. All right, that's an interesting little thing. We mask it. This is now calling that. So basically that will be an FF00 and that will be a 7F. And that will be our 7F. And then when we do this next, we pop the status register It didn't really matter what it was. So it shouldn't really matter that we get to that point. Though, was that actually access granted? Right, it just doesn't pop it up because we've like already succeeded. Right, so in Whitehorse, was it? We do a continue, and it is hex string. So maybe this string we I could do something like that. I don't know. And maybe get that from there. Right, so it's got me. It's doing a 7E check first. That's all right. Maybe we'll do a fin. I guess like I could have it go to this one after the so this intermediate address we could have is 1C51 1C51 and they'll just make it get to this point here. But for now, this we're still in like puts. All right, let's just continue. Are we like in a? No, we're just doing like lots of puts. Cool. So we have solved it. And that was without the other stuff, but like, hey, what else? Cool. Wonder why that didn't really work the first time. Yes, I wonder why. I wonder indeed. Do another maybe. I don't know, how many have I done? I don't want to like do them all in once. Yeah, I'll do another. Right, so what's this doing? And did it give like a little hint? Well, they've got a internal security development thing. Who knows what that means? Right, so we do a login. It looks like we're potentially overflowing login again because of this setup. And yeah, that does the 7E. And what's happening here? So we're allowing 16 characters. If we overwrite that, that's more than that. We get that. We do a string copy, so it's got to be like a valid string, I guess. And is that where we got our string? Yeah, so it first copies it. All right. maybe I want to kind of see what's happening here. And what we can do is maybe just start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 9, A, B, C, D, E, F, and we can copy that a few times, so it will overflow at some point in there. But if we continue from here, so at 2400 we have all my bytes, so 1, 2, 3, and it does that twice. So we have 16 bytes that we can. Well, we have these 16 which we were meant to write to, and we also have these 16. We can write some code there potentially. Right, so we do a string copy. So I think I want to do this. And where's the string copy going to? It's going just directly to the stack. Is that what I'm reading? Surely not. We'll find out. It just went directly to the stack. So at this point here, we've like just destroyed the stack. So we put it here and we get up to there. And now we are clearing 64 bytes of our original address, the 2400. So this should all go back to 0, aka disappear from that. Yeah, so that doesn't exist anymore. It's only where the stack was, which seems bizarre. Right, so at this point here, we put our stack pointer, which is pointing to our password, and do this conditional unlock. That's all right. It's not going to pass, so R15 is 0. And then we're just going to add 10 to the stack, so basically to where we were. But if I did this whole thing again, so yeah, if I did this whole thing again, but instead of say instead of the CD, I do a 0, 0. If I do that and continue, at this point here, yeah, so we have 0 bytes there. And at this point here, we, I want that one, do a string copy to here, but we only actually copy up to the null byte, which means that after this mem set, the original is gone. So whatever we put in there, we're not allowed null bytes. That's what that means, in essence. Cool. So what is a decent password that I can put in? So really it will be overriding this address here. So what do I want to groom that to look like? I can just go to int again. So this will be 4C45, and these 4 bytes I want to be 7F00. Is it that way around? And then the rest I don't really care about. I hope it was that way around, because otherwise how would we get it in? So if we do this, and see what we look like. So we do the string copy, and we only copy what we need. Yeah, so that isn't quite right. How much did it add on? It only added on 10, but it must do some other stuff in the meantime. Right, so we mem set, we do the condition one lot. We don't get in. That was quite jarring. Password is not correct. Maybe if I just do a thing there. Reset, continue, put in that, continue. So if I do a continue to here, where are we looking at compared to my data? Yeah, so I need to add in like a bunch more. Oh, I see kind of what my error was. So each of these digits is taking up a nibble. So like half of a byte. And so I really need 2 lots of 16 to pad it out to the amount that I need. So I think this is what I need. So if I go reset, continue, put in that, continue again, and like here we can kind of see what's happening. And here our stack pointer, we haven't got there yet. Did it get to where I want? What? Or have I like proper broken it? Reset, buddy. Reset. I might need to like have a little reset, full reset of this. So has it has not cleared my things. That's all good. So if I go continue, put that whole string in there, there's no zeros. I think I need like a couple more from there, but maybe if we continue from there, like head to here, where are we looking? The 4C45 and the 7F00 is the next thing. So if we step, we should be in our int. I've done that thing. So we want 4 random characters in between. And so, yeah, if I do continue, here should continue to that point. It's still not taking what I expected. Reset, continue, shove in all of that. We can't have these 0 bytes. 0101. That's just what it will be. So if we continue from there, we continue from there. So at this point here, where are we looking? We are looking at a 4C45, and we don't. Yeah, so perfect. So we'll go there, our stack's point there. We get the 7F, we do some things. It's unlocked. Perfect. And it's likely the same password. One of these, they'll mix it up and we'll be like, actually, we are now doing like a relocated memory. But for now, all the memory seems fairly static, so we can do tricks like that. I think for now, I'm going to leave it at that. Just to give you a little intro of that, and I'll hopefully come back to this because it's kind of fun. But for now, I'll see you. Thanks.